Hi everyone, it's Mr. Hamilton here. Today we're going to do an investigation between the perimeter and area of rectangles. And so what we're going to do to start is we're going to start with an area, and we're going to see what dimensions, length times width, are going to give us the smallest and largest areas. And then we're going to be given a perimeter and try to determine what dimensions are going to give us the largest area. So here we go with this first part. A rectangular pet exercise area is to have an area of 36 meters squared. So step 1, sketch all the rectangles that have whole number dimensions and an area of 36 meters squared. The hint is that there's only 5 possible rectangles. A square is considered a rectangle. So here's the first one. If I let it be 1 times 36, it's 36 long and 1 wide, that has an area of 36. So the length is 1, the width is 36. Another possibility is if I make it be 2 times 18. So this is 2 and this is 18. 2 times 18 again would give me an area of 36. But as you can see, if I look at the first rectangle, if I walk all the way around and figure out the perimeter, I would be walking 1 plus 36, it'd be 37. And then I do that all over again, so another 37. And so that perimeter of that first one is 2 times 37, or 74. But yet the second one, I'm going to go 2, then I'm going to go 18, so I'm going to go 20 along those two sides, and then I'm going to do it all over again. 20 more is a perimeter of 40. And so what we're trying to do is we're trying to figure out which one of these is going to have the smallest perimeter. We're going to keep going with this pattern. So if I do 3, then I'd have to have 12 on this side. 3 times 12 would also give me 36. If I keep going, then I know this isn't to scale, but it would be 4 on this side. 4 times 9 would also give me an area of 36. And then we said a square can also be a rectangle. We could make a square that has 6 by 6. So what we're going to do now is we're going to fill in the chart below, and we're going to compare the length, widths, perimeters, and obviously the areas all being the same. So here we go. The first one has a rectangle 1 that we've drawn in the top left, has a width of 1 and a length of 36. The perimeter is, as we already said, it's 1 plus 36 plus 1 plus 36, which is 74 meters. And we know all of these have an area of 36 meters squared. The second one has a width of 2, a length of 18. And if I go 2 plus 18 plus 2 plus 18, all the way around, that gives me a perimeter of 40. And again, it had an area of 36 meters squared. The next one is 3 by 12. And that's 3 plus 12 times 2. It's plus 3 plus 12 all over again. And that gives me a perimeter of 30. Again, an area of 36. The last two are the 4 by 9 and the 6 by 6, and I'll fill those in here. When it's 4 by 9, the perimeter is 4 plus 9 plus 4 plus 9, or 2 times 13, which is 26. And again, we have the area of 36, because they all have an area of 36. And the last one was the 6 by 6 square, which is going to have a perimeter of 24, because it's 6 4 times. So that's 6 by 6, and that has a perimeter of 24, again having an area of 36. You'll notice I didn't do anything for a side length of 5, and that's because it doesn't divide evenly into 36, so we'd have a decimal value for the other side. And we don't want that. So here's the questions that I want us to reflect on. What dimensions use the least amount of fencing? Well, they're the 6 by 6. More specifically, it's the square that uses the least amount of fencing. What dimensions use the greatest amount of fencing? Well, they're the 1 by 36 dimensions. The longest and skinniest. That uses the greatest amount of fencing. What shape would you choose for your pet exercise area? Now, if I had you in front of me and we were actually having a conversation around this, some of you would say, I choose the long and skinny one because I want my pet to be able to run very far and back. But here's the thing. you're going to pay more than 3 times as much for that fence than if you got a square one and had the same area. Because here's the comparison. The square only used 24 meters of fence, but this really long skinny one used 74 meters of fence. So you might think it's worth it to spend more than 3 times what I would for the square fence on your dog or on your whatever pet it is. However, I want to save some money, so I'm going to go with the smallest amount of perimeter, which is going to be the cheapest fence for that area of 36 meters squared. So I would say I would use the square, and the reason would be it would be the cheapest fence since it's the smallest perimeter. So we could have a really small perimeter, but we can still have the same area as something with a very large perimeter. So what are the takeaways here? Let's just summarize this at the bottom here. Rectangles with the same perimeter can have different dimensions and contain different areas. And rectangles with the same area can have different dimensions and different perimeters. This is the second point, is what we just discovered in this investigation that we did. Here's the main takeaway that you need to have from this section. You can put it right up here with a big star beside it. The square has the minimum perimeter for a given area. The square has the minimum perimeter always for a given area. Now this is if we need all 4 sides of the square. The other thing is that the max area for a given perimeter is also a square. A square is the max area for a given perimeter. So those are the things to keep in mind. Anytime you're asked, if you're given an area and you're said, minimize the perimeter, you make a square. If you're given a perimeter and you're said, maximize the area, you make a square. The key is that it's always going to be a square. Let's see how this actually plays out with one practical example. So here's a great question to consider. What's the largest area you can fence in if you have 22 pieces of 2-meter long fencing? So some of us are inclined to think, well, that means I have 22 pieces of 2 meters long. I have 44 meters of fencing. And so we know that the largest area that we can make is always, with a given perimeter, is going to be a square. So some of us might look at this question and we'll say, well, I have 44 meters of fencing. That means 11 meters on each side. There's a problem with this. Because if there's 11 meters on each side and each piece was 2 meters long, that actually means I have a half piece on each side. What did I do? Cut those pieces of fence in half? So here's the deal. We cannot cut fence pieces in half. I guess you could if you wanted to, but that wouldn't be very good for the rental company you rented it for. Say this is for a concert or something like that. And it wouldn't make the fence work practically. So what we have to do is we have to start with these 22 pieces and then think about where we go from there. So we've got 22 pieces. And if we want to make it as close to a square as possible, we are going to divide by 4. For a square, we're going to take the 22 and divide by 4. Well, that would give us 5 with 2 remaining. So what we have is 2 pieces remaining. So another way to put that would be this. We could say it's 5 pieces per side plus 2 remaining leftover pieces. So if I just ignore those 2 remaining leftover pieces, if I say 5 per side, I would have a square. That's 5 per side, and if I have 5 pieces per side, that means because each piece is 2 meters long, it's going to be multiplied by 2. That's going to be the length of each side. So in other words, each side is going to be 10 meters long. We're going to have 4 sides. This is going to be 10 meters over here and 10 meters over here. And so you would say the area of this square is 100 meters squared. Well, that's great. We're doing really well. But what about those 2 remaining pieces? Well, how can I add them? We can't cut them in half and make it 11 by 11. That would be an area of 121. But what we can do is we can add one more piece to 2 of the sides. If I put 6 pieces here and 6 pieces here, and then keep the 5 pieces there and there, now I've used all 22 pieces. And so each piece is 2 meters long, so the actual length is multiplying each of these by 2. And so what we would get is we would get a dimension of 10 equals 10 by 12. And so that gives us an area of 10 by 12 of 120 meters squared. This is the largest area. So the key is to build a square. The key is to build a square and add the remaining pieces on 2 sides. 2 opposite sides. That's the key strategy for a question like that. And that would be excellent. If you were in the business of running a concert like here in Ottawa where they have to put the fencing all around, that's a great strategy to be able to maximize the area by using those pieces of fence. So if you're in the academic class, let's consider now when we have one bounded side. In other words, we only need to fence in 3 sides with a given perimeter of fence. So here's the situation. A rectangular pet exercise area is to have a perimeter of 12 meters. It's to be built against one side of a house, so it only needs 3 sides of fencing. So we're going to sketch all 4 of the rectangles that have whole number dimensions and a 3-sided perimeter of 12 meters. I'm going to do the first one, and then I want you to pause the video and try to do the other ones yourself. 1 by 10, so there we have 12 meters. The area there is going to be 10 meters squared. What's the next one going to be? Well, now I'm going to put 2 on this side. And then if I put 2 here, and I have 12 meters of fencing total, well, I only have 8 meters left for this side. Well, the area of that, 16 meters squared. See if you can continue that and then compare your answers with mine. Pause the video now, and I'll put the answers up when you replay the video. So there are my 4 diagrams. And now I haven't driven them quite to scale, but hopefully you can see some interesting features here that the square is not the biggest area. Let's fill in the chart below here as we make some conclusions. The first one was has a width of 10 and a 1 and a length of 10. So the perimeter of that one was 12. They were all 12. The second case was 2 by 8. The third case was 3 by 6. And the fourth case was 4 by 4. Let's just get rid of that wild line that got drawn. All right, so what's the area of these? 1 by 10 was 10. 2 by 8 was 16. 3 by 6 was 18. And 4 by 4 was 16. The biggest area was 18. And you'll notice that the area of the 2 by 8 was equal to the square. So what we want to specifically note is how does the width and length compare in this particular case? Well, the length is double the width. And that's exactly the case when we already have one side that it plays out. There's 2 squares beside each other. The length is double the width. So let's go ahead and answer these questions down below. Does the square have the greatest area? No. What dimensions give the greatest area? The length is double the width. Length is double the width. So it was a 3 by 6 that gave us the greatest area. So describing the ratio would be saying the length is equal to 2 times the width. Would be one way to say that. Which shape would you choose for the pet exercise area, and give reasons for your choice? Again, I want to save money and maximize area, so I would choose the 3 by 6 since it maximizes the area for a given perimeter. All right, or for a given amount of fencing. So what's the conclusion? Rectangles with one bounded side have the greatest area for the least perimeter when we have a situation where the length is double the width. So when the length is equal to 2 times, I'm going to use the curved L, 2 times the width. So remember that. If we have a given side, the length is twice the width, but if we know all 4 sides, if we need all 4 sides, it's always going to be a square.